Welcome to the Holcomb Department of Electrical and Computer Engineering. Thank you for taking the time to do our virtual tour today. My name is Amanda Harris and I'm staff in the ECE department, and today I'll be telling you a little bit about electrical and computer engineering, our department and curriculum, and some of the opportunities that we have here. Now, if you were able to come on a tour on campus today, at this point we would be welcoming you to Riggs Hall that you see here on the screen. Riggs is the home to the ECE department, so it houses our undergraduate labs as well as our administrative offices. So that includes the department chair and all of our student services staff. In ECE, all of our undergrad students will be assigned a faculty advisor, but we also have 2 dedicated staff members who are just there to advise and be resources for our undergrad students. We also have the main college offices here in Riggs Hall. So you have the dean, the associate dean for undergraduate studies, the international outreach offices for the college. So it's just a really nice central location for a lot of resources that our students need. One thing to kind of start out with, you'll note that I said we are the Holcomb Department of Electrical and Computer Engineering. We are one department, but it houses 2 separate majors. So when you graduate from Clemson, you will have a degree in either electrical engineering or computer engineering. And some of the questions that we get a lot are really about what's the difference between electrical and computer engineering, and often how does computer science fit into that? So what do electrical engineers do? Electrical engineers are involved in the design and development of virtually anything that uses or generates electricity. So as you can imagine, that is just about any and everything these days. They work on harnessing electricity for anything that needs it, focusing on the hardware side of the systems. This can be anything from as small as microchips or as large as industrial robotic systems and power plants. This work has advanced areas of electronics, communications, power, and digital systems. So then what do computer engineers do? Computer engineers are going to deal with the engineering of computer systems. You can kind of think of them as the bridge between electrical engineering and computer science. While the computer science folks, they're going to focus more on just the higher level programming. Computer engineers interface all the layers of a system. So that's from hardware to software and networking capabilities. So this can be working with anything from a typical PC to supercomputers or microscopic embedded systems. There are applications for computer systems in almost anything today: automotive applications, robotics, computer networks, medical systems. Basically anything that has a processor, a computer engineer has had their hands on it. Now there's obviously a lot of overlap between electrical and computer engineering, and overlap between computer engineering and computer science. And so we kind of like to illustrate that a bit with this pyramid system here. So you can see electrical engineering on the bottom is going to be your base. It's going to have all of the hardware, materials, power systems, and that will overlap a little bit with the computer engineering with your digital circuits and logic gates. Computer engineering then gets into computer architecture and overlaps on the computer science side with languages and operating systems, where computer science is going to have those high-level applications and programming that you're not quite going to get into as in depth with the computer engineering. One thing that's really nice about how that overlap works out with our curriculum, you can see here these are the core coursework areas in electrical and computer engineering. You've hopefully learned a little bit about the common freshman year in general engineering, and a nice thing in our department is once you declare what your major is, in our department the sophomore year is virtually the same between electrical and computer engineering. So you almost have that extra year to really decide what track you want to go down. And you can see that overlap is there with the circuits and electronics that everyone really has to have a good basis in. And then for those who go on to major in electrical engineering, your coursework is going to branch off into communications and controls, power systems, digital systems, and electromagnetics, while the computer engineering students are going to get further into computer hardware and computer software. These courses are completed in the sophomore and junior year, and then some of your senior year you may still be kind of finishing up 1 or 2 of these along with your technical electives that we'll talk about in a minute. A couple things that we like to point out about these classes: because these are the core required classes, we have them offered every semester. So that's fall, spring, and summer online. So that allows students to take these classes whenever they need them. You don't have to worry about if you're on a co-op rotation, getting out of sync. Anytime you need to take one of these classes, they will be available to you. Another good thing about these courses is they are usually taught by teaching faculty. So these are professors whose primary responsibility is just teaching and advising undergraduate students. They don't have their time split between instruction and research demands, so they can really focus on our undergrad students and give them a really strong foundation in these core courses. Along with that, we do like to point out that we do have graduate student TAs who are teaching labs, but in your ECE classes, you will have a professor teaching. Then into your senior year, you will take your technical elective courses. So these classes are where each student has the freedom to choose what technical elective courses they take based on their interests. So these courses let our students kind of become more knowledgeable in a specific area, so they're better equipped for a career in industry if they know what track really interests them, or if they know they're interested in graduate school. This is a good way to get them a little focused on a potential research area. Also, some students choose to take their technical elective courses from various topic areas, and that way they get exposed to a wider range of these specialties in electrical and computer engineering. These courses are generally taught by our research faculty, so they're constantly being updated, kept up to date with what's going on in industry, current research, all of that. And we also have completely new specific courses that are always added to this list. One thing to note, the list that you see here on the screen, that is the list of the topic areas. So for any one of these kind of umbrella areas, there are going to be several classes in each of those focus areas that students can choose from. These classes are also why we counsel students not to double major in electrical and computer engineering if that's something that they're looking at. For one reason, these technical electives are an opportunity for students to kind of get that look at the other side of things. If they're an electrical engineering student and they have a little bit more interest in some of the computer engineering side of things, they're able to take some classes to get that exposure. And likewise, for computer engineering students, they can take some of these technical electives that are a little bit more on the electrical engineering side of things. So you aren't really stuck in one track. You can get exposure to all the different areas. These courses are also what makes the BS to Graduate program possible. So normally an undergrad student would take these classes at a 4,000 level, which is a senior level course. But students who are interested in that BS to Graduate program track would take these at a 6,000 level, which is graduate program level. So that way they're kind of double dipping. You're taking these classes to finish up your undergraduate degree, but then those credits also count towards your graduate degree. So that really speeds up the time that it takes to get a master's or a PhD. Also in your senior year, you're going to be participating in our senior design courses. So this is our capstone design sequence, and it's split into 2 semesters. So you're going to have 2 separate semester-long projects where you're working with a team of 3 to 4 other electrical and computer engineering students. With these projects, you're going to be looking at everything from beginning to end of the life cycle of what it takes to develop a deliverable robotic system, as if you were going to present this to your boss in a real-world work environment. And the first semester projects are usually a little bit simpler, and they're a lot more guided by the faculty and the support TAs. So you're going to have very clear milestone schedules that break down every step of the project. The second semester projects are usually a bit more in depth, and the student groups have both a lot more freedom and responsibility in completing their project. They're basically given the brief on what they need to make and told, this day in April is when this is due, make it happen. So along with the technical aspects of designing and building and programming these systems, student groups, they also have to develop project management plans for these projects. They have to work out their schedules for deliverables, financing, doing evaluations and reports on any ethical or environmental concerns. They have to do post-project evaluations. So really everything that would go into building a project, not just the physical system and the programming. They really have to think about this in a holistic way, as if this was their job. So it's a really great hands-on experience. So some of our past projects that we've had, you can see here on the screen on the very right, this is a first semester project, and that is the Towers of Hanoi problem. So it's a kind of visual sorting problem that the students had to work out. We have done here in the middle top, this is a electromagnetic floating system. They have done automatic guitar tuning systems, you can see here, and air hockey playing robots here on the very left. That is one of our favorites that comes up quite often just because it's so much fun. There are always lots of different projects every semester, but our favorites kind of come up again and again. So at the end of the semester, when these projects are due, we have a demo event. We invite the department, order pizza, and really showcase all of these projects. If there are competitive projects like the air hockey playing robot, we usually set up a tournament among those builds to determine a final winner. Another cool thing about these demo nights, we usually have industry representatives that attend to be a part of the review panel that evaluate all the projects. So that's just another good networking opportunity for our students. And it, again, is also just a really fun time to show off what they've done. So as I mentioned, there are a lot of different projects that we have done over the years, and they're constantly changing. So we do have a Facebook page for that Senior Design Showcase, and if you want to check that out, there is the link and a little QR code to send you there, and you can see tons of videos from past projects, the final presentation videos, so you see what all went into each project from the student's perspective. Also, outside of the classroom, we have a lot of our students who will participate in co-ops and internships. You see the numbers here, about 35% of our students will participate in a co-op, and another 60% will participate in internships. And there is some overlap there as well, because there are students who will do both. If you haven't heard about our internships and co-op program, it's a really great opportunity here at Clemson. We have our Michelin Career Center that really runs the co-op program. And the difference between a co-op and an internship, and partially to explain why there are fewer students who will do the co-ops, a co-op is a 3-semester rotation. So you're kind of locked in with a company. You will go usually summer after your sophomore year, and you will co-op for that semester. You'll come back to school and do a semester, you'll go on another co-op rotation, and go back and forth like that. So you end up really with a year of experience. So you are kind of locked into that a little bit more, and it will generally add time to your graduation date. But while you're on those co-op rotations, you're not paying tuition. If you have scholarships, those are put on hold. You can pay a nominal student fee, and you still have access to everything at Clemson as if you were, on campus as a student. And really, if you're interested in that, our Michelin Career Center and their co-op office walks you through the whole process. You would basically go into their office and say, this is my major, I'm interested in co-oping, these are the kind of companies I'm interested in, what I want to do, and they really build you from the ground up. They will set up mock interviews, they help you put together your resume, and most students, we will have a co-op fair in conjunction with the regular career fair every semester. And so students who are interested in co-oping who go through this process, they'll generally have, anywhere from, 5, 6, 7 interviews over a day or two, depending on how many companies they're interested in. And it's really just like a job interview. And a good thing to note with electrical and computer engineering, we have more co-op opportunities than we have students to fill them. So if you're a decent student and you're interested in co-ops, you can almost be guaranteed a position with a co-op. Internships are a little bit more self-guided. They're more on the student to find. Generally, those are just for a summer term, but you can it's whenever you find an internship. We have students who will do internships in the fall. We do have students who will have a recurring relationship with that internship, so it doesn't have to be just that one summer and then you don't ever have anything to do with that company again. You can build on that relationship. It's just with the co-op, that's kind of built in. And really what this sets our students up for is at graduation, about 70% of our students have a job offer in hand as they are graduating. So that's really nice to know, that you have that kind of in your pocket. Another 32% plan to attend grad school in engineering. We do a lot of math in this department. We know that doesn't add up. So that overlap, those are the students who, they have that job offer, but they are opting to turn that down to continue on in grad school. And I think that just really speaks to how well our faculty really instill that, love of knowledge and the excitement about these areas that really, it spurs students to want to stay and learn more. But if you're not interested in grad school, it's nice to know that you do not need a graduate degree in order to start a well-paying, good career in ECE. You can see the average median starting salary for undergrads is $66,000. That's a nice thing to kind of have waiting for you. Our students will tell you, though, if that's your only motivating factor for joining ECE, it will be as they say, a really hard 4 years while you're here, and an even harder 40 years afterwards in a career that you don't really like. So just keep that in mind. Make sure that you're doing something that you're good at that will, get you a job, but also that you just like, that you're going to enjoy. And so speaking of that, I know we've said several times that, with electrical and computer engineering, they're just everywhere. There's almost no industry that doesn't need an electrical and computer engineer. But just to give you a few specific examples, this is over about the past year and a half where several of our graduates have gone, just so you can see the companies where people are going and the positions that they're taking. So we have students who are working with Google, Boeing, doing software engineering, mobile development. You can see here, this is a computer engineering student, took a job that was, the position was called electrical engineer. So you don't have to feel like you're stuck in one track or another with either of these majors. A short list with electrical engineering. We have a lot of students who will go into power, ExxonMobil, you can see chemical companies, and all the way to working with Universal Resorts. So there's really not anywhere that you can't go with electrical and computer engineering. It's really just what interests you and what you are looking for in these careers. And a very, very brief list of a lot of the companies that we continually see our students go work for, who always come in for our career fairs. And it's everywhere from small companies that are regional to Amazon, GE, ExxonMobil. Again, really anywhere that you want to go, you can do with electrical and computer engineering. Thank you so much for taking the time to visit our department today. Normally, we love having questions during these presentations, but of course, this is all virtual. So please, if you would like, check out our website and email me if you have any questions, anything that you want to know more about, anything you're interested in that maybe you didn't hear about so far today. Just reach out to me with that, and I will get you all the information you need and get you connected with our student services people if that would be helpful. But otherwise, have a great rest of your day, and we hope to see you here at Clemson soon.